Kara, thanks very much. Hello, everyone. I'm very pleased to be participating in this talk about two very, very important engineering disciplines and how they can come together. I'm going to take a product line engineering perspective primarily because that's what I do these days and that's what my company, Big Lever Software, does. And by product line engineering, I mean the disciplined, efficient engineering of a family of similar products. PLE has emerged as an engineering paradigm with probably one of the largest ROIs that we've ever seen. And by product line, I mean, as I said, a family of similar products, but they're different. They have variations in features and functions. And PLE is about the efficient engineering of those in a way to take advantage of the commonality and the similarity, yet while respecting and managing the variation among the products. Our particular approach to PLE uses a shared set of engineering assets. This is whatever you use to build and deploy your products, requirements, tests, code, bills of materials, user manuals, anything. A managed set of features with which to describe the products, and an efficient means of production that I'll talk about. The paradigm that we offer, the modern automation-based paradigm, uses the metaphor of a factory. And here's a visualization of the factory. Over here on the left, think of this as the supply chain. These are the shared assets, these engineering artifacts. There are examples shown here, but it is in general an open-ended list. Shared assets that you use to support your product portfolio come into the factory on the left. And at the top into the factory comes a description of the product we would like it to build right now, because like all modern factories, ours just doesn't build multiple copies of a single thing. It builds a family of things, and we need to tell it what to build. We describe the product we want it to build by describing its features. A feature is a distinguishing characteristic that sets product apart from each other. And so we feed the factory a bill of features, or a feature profile, if you like, which describes the features of the product. And this bill of features is drawn from a feature catalog, which essentially is the set of features you can find in any of the products across the entire portfolio. And this automation-based approach relies on a configurator. In our case, this is called Gears. It's the tool that we sell along with our methodology and organizational change services. And Gears configures the shared assets on the left according to the feature description of the product that you feed in from the top. And so that's the factory paradigm. So features come in, shared assets are configured accordingly, and a product comes out just like a factory. There is a common motivation that we see in organizations that adopt this paradigm. And I will be candid, adopting the paradigm completely is not an easy matter. If PLE were easy, everybody would be doing it, given the enormous ROI and benefits that we see from this engineering approach. It's hard. And organizations that do this, do it because they see a competitive advantage in it. That's what it is about. This is very much a business decision to adopt this approach, as much as it is a technology decision or an engineering decision as well. These are some of the companies that Big Lever works with, and you can see the competitive advantage statements that they have come up with. So there's Lockheed Martin at the top. I'll be talking more about them during this talk. $47 million saved per year, which they mark up to product line engineering. There's General Dynamics, over $660 million saved over 12 years. These are